Example, evaluate the integral from -2 to +2 of the function 15x to the fourth minus sine cubed x dx. We begin this problem by checking for symmetries. That is, we compute f of minus x. We're going to put in the negative x every place an x is present. So we'll have 15 times negative x to the fourth minus sine cubed of negative x. That would be equal to negative x to the fourth is just positive x to the fourth, so 15x to the fourth. We remember that sine is an odd function. So sine of minus x is minus sine of x, and cube that. That's still a negative. Minus negative gives you plus the sine cubed of x. Notice that that's not the original function, and it's also not the negative of the original function. Thus, this function is neither even nor odd. Even so, we will continue. We will now write the integral from -2 to +2 of 15x to the fourth minus sine cubed x dx as a difference of two separate integrals. That is, the integral from -2 to +2 of 15x to the fourth dx minus the integral from -2 to +2 of sine cubed x dx. We'll check for symmetries for the two separate integrals, beginning with the 15x to the fourth. F of minus x is 15 times where the x was, we replace with negative x to the fourth. That is equal to 15x to the fourth, which is the original function. We have shown that f of minus x equals f of x for f of x equals 15x to the fourth. Thus, f of x equals 15x to the fourth is even, and we can compute the integral that's from -2 to +2 of 15x to the fourth dx as twice the integral from 0 to 2 of 15x to the fourth dx. Let's check for any symmetries of the sine function, that is, compute f of minus x. That would be sine cubed of negative x. If it's helpful, put brackets around the sine of negative x and then raise that to the cubed. Then working from the inside out, the sine of minus x is minus sine of x. Remember, sine is an odd function. We have negative sine x cubed. The negative raised to a power that's odd results in a negative, so the bracket negative sine x raised to the power of 3 is negative sine cubed x. Sine cubed x is the function, so we have minus f of x. We have shown that for sine cubed x, f of minus x equals minus f of x. That is, f of x equals sine cubed x is odd, and the integral from -2 to +2 of sine cubed x dx is 0. So, our original integral, -2 to +2, we integrate from -2 to +2 of 15x to the fourth minus sine cubed x dx is twice the integral from 0 to 2 of 15x to the fourth dx minus 0. Remember, sine cubed x from -2 to +2 is 0. Thus, we only need to find the antiderivative of the 15x to the fourth. The 2 stays put. You raise the power by 1, so it becomes x to the fifth. 1 over 5, 15 divided by 5 is 3. So now you have 2 times 3x cubed evaluated from 0 to 2. Let's evaluate. Maintaining the 2, that's the constant, you have 3 times 2 to the fifth, putting in 2 where the x was, minus 3 times 0 to the 5th, putting in 0 where the x was. The rest is arithmetic. We'll have 2 times, and in the brackets 3 times 2 to the 5th is 32, which is 2 times 96, and so our integral is 192.